Hi everyone, let's have a look what's going on now. This is the first of the Trig videos that I'm doing, which actually going to show you how to do some of the calculations. From the previous video we talked about if we compare any two sides of a triangle and we name the sides of the triangle, we can relate that to what's stored in our calculators. When I was a kid it wasn't stored in the calculator, it was on a piece of paper, but the accuracy you can get now is much more accurate and easier to access than what I could do when I was a child. Looking at these sides that are here on this triangle, back traditionally people would talk about using the angle of 20, we're going to compare the length of this side, which we're trying to figure out. You could obviously measure it here, but let's do it as if it's algebra. And the actual calculation compared to the length of that side. Now traditionally people then started coming up for names for it. This one was obvious. For millennia, for thousands of years, that one was called the hypotenuse, so we didn't have any problems with that one. And the one that's across from the 20, like I was talking about in the last video, I'm looking out my front door, the front window, I look across, there's some neighbours who are opposite me on the other side of the road, they're opposite. I'm looking across to them from here. So looking across to this side from the 20 is called the opposite. Instead of writing the whole word out, I want to leave myself some space. I'm trying to keep to one board to keep my videos short. So I'm going to compare the opposite with the hypotenuse. Now, I can write a fraction from them. I could put the opposite on the numerator and the hypotenuse on the denominator. I could put the opposite on the top and I could put the hypotenuse on the bottom. But I could also do the other way around. Put that on the numerator and put that on the denominator. The system that was chosen was to put the opposite on the top and the hypotenuse on the bottom. Chosen a long time ago by lots of people. And the name it was given, if you want to look back at the previous video, I talk about why they got the names, was called sine. So it's actually the word sine. Let's have a look what's happening, and then we talk about the angle. So the sine, or the ratio, or the fraction that we're going to write down from that triangle using 20 degrees. So let's have a look what it is. So the sine of 20 degrees, you write the length of the opposite, but we don't know the length of the opposite. We're trying to find the length of that side of the triangle. So we replace the word opposite by the x, and then we replace the word hypotenuse by the length of the hypotenuse. I've already got it written here. For those who are watching and see I'll be a little bit inaccurate on this, that's actually 32.5. But for the moment I'm just going to do it rough. I'm going to do it as 32. And you end up with this thing, sine 20, which a lot of people don't understand. And the other problem here is we're back to equations and how many people struggle with equations. When you have an equation, you want the equation to tell you the answer. We want the equation to tell us how long that side is. You can see from here it's about 11, over 10, it's about 11. So we have a look at what we're actually going to get. When I have an equation, I want to balance up both sides. It's like having a seesaw here or a set of scales here. And if I make one side heavier, I've got to make the other side heavy to balance up. If I have two kids on this side, I balance it up, try to get two kids about the same size on the other side. So to solve the equation, this has got to divide by 32. If I want to get rid of it divided by 32, I can go multiply by 32. And just remember that's a numerator and that's a denominator. That's a top and that's a bottom. So if I times this side by 32, I times that side by 32. Let's have a look at what we've got. 32 over 32 is 1. How many times does 32 go into 32? Once. I thought about making these easier numbers, but I had the diagram here already, and I thought I'll stick to the numbers I've already got, because 32 into 32 is pretty obviously going to go into once anyway. So they actually cross out. A lot of people do write down that that's 1x, but you don't need to write the 1. Now I pick up my calculator, and the number for sine of 20 is stored on my calculator. Please be careful, your calculator says in little letters D-E-G. That's where you're using degrees. If you're in France and you're doing this question, you won't use the 20 and the degrees, you'll use a thing called grads. And if you're in high level maths, which is year 11 and 12 in Australia, in the higher courses or the more academic, more challenging courses, they'll have another thing called radians, which is different altogether. So be careful. When I first picked up this calculator that I haven't used for an awful lot of years, maybe 20 years or more, and the battery still worked, which is quite amazing. it was set actually on the wrong one. So I had to change it back to degrees. So I'm going to type in, I'm going to go to 32 multiplied by, and I got 32, I hit the multiply twice, 32 multiplied by, and I press the sine button, the one that says SIN, and I put in the 20, and I press it equals, and it tells me that the answer would be about 10.94. So I could write more decimals, and I could write it, most people traditionally would write the X first. It's not such a big problem these days. So 10.94 is about 11, and if we were using centimetres, it means it's about 11 centimetres. It's nice for me to have this little diagram up here, and you can see that was 5, 10, 11. So then you, of course, some students will say, couldn't you just measure it? But in real life, you can't always measure things, like you might be looking across a river or a canyon or up a cliff, and you want these distances, and you don't want to, you want to be able to not go across in mid-air and across the river and figure out what it is. So that's how we get that one. So let's go down to the same thing down here. So this one is also going across from there, and that's called the opposite. And then this one over here is called the hypotenuse. I find very few, if any, students ever have trouble with the hypotenuse. It's the longest of the three sides. This one looking across here again is like looking out here across to the other side, and there's the opposite. So just like I did before, to get the sine of any of that angle, I'm going to compare the length of the opposite with the length of the hypotenuse. And a lot of people shortcut it and just put it as over h once you get the hang of it. Let's put the numbers in. So this one will be the sine of 30. And the opposite has got the letter x, which means we're trying to find how long it is from there all the way down to there. That's what we're trying to actually calculate. Then you compare the length of that with the length of the hypotenuse, which is 35. And I'm running out of room a little bit. How do I get rid of a divide 35 on equations? You want to balance up the two sides. If I multiply this side of the equation by 35, I have to multiply this side of the equation by 35. And then how many times does 35 go into 35? Remember, that's the top and that's the bottom. So you can cancel top and the bottom. So you could say 35 into 35 goes once, and I could write down 1x. A lot of people just cross out the 35s. It's not that they become 0, they become 1. So some ways it's easy to go 35 into 35 goes once. We don't have to write the 1 for algebra. Put it in my calculator, and now I can go 35 times the sine of 30, and I get 17.5. Let's have a look up here. That was 5, that was 10, that was 15, that looks like about 17.5. So we can use sine to get the length of those sides. On the next video, I'm going to come back and do the same questions again, but so the video doesn't become too long, I'll cut it short here, and we'll come back and do it with a different way of thinking. I shouldn't say different way of thinking, with a different use of trigonometry.